Back in 2008, when we started the definition of the Zynq-7000 architecture, we quickly realized that given the embedded nature of the target application for Zynq, it was essential to provide a product that would offer a high level of performance while also maintaining the lowest power consumption possible. Looking at this challenge, we knew we had to make important architectural decisions, but also needed to select the best process to get the results our customers were expecting from us. Very quickly, it became clear that neither the 28nm low-power process nor the 28nm high-performance process would serve our needs. While the 28nm high-performance process would give us the required performance, its power consumption would have kept Zynq away from most of the deeply embedded applications. And the 28nm low-power process would not have offered the performance required for demanding applications such as wireless and embedded vision. So we worked with our foundry partner TSMC to create an entirely new silicon process at 28nm called HPL, or High Performance Low Power Process. This HPL process is ideally suited for the requirements of all programmable FPGAs, all programmable SoCs, and all programmable 3D ICs. Since its creation, HPL has delivered exactly the right amount of performance and power savings for the type of application customers address with all programmable devices. Now, while the HPL process would give us a solid foundation for these new devices, for example, allowing the processor core to run up to 1 GHz, which is 25% faster than our competition, we also made important architectural decisions to deliver on both power and performance requirements from our customers. We first looked at how we could improve the processing system architecture compared to typical implementation of the dual-core ARM Cortex A9. Among others, one major architectural decision that allowed us to deliver higher performance in Zynq devices is the way we implemented the accelerator coherency port. While ACPs are typically routed through the main processor switch with multiple hubs, we gave Zynq accelerator coherency port a direct connection to the FPGA Fabric. This considerably reduces latency of data transfer on this port, which in turn allows customers to get the best performance out of the accelerators they implement in the FPGA Fabric. That being said, having such a high-performance processing system also requires an equally efficient memory architecture. For that, we made three important decisions while defining the memory architecture. First, we gave Zynq a 256 KB on-chip memory, which actually is 4 times greater than our direct competition. There are many reasons why we chose to implement a memory of this size. Just from a performance standpoint, it allows the Zynq device to run a complete real-time operating system inside the on-chip memory, while also facilitating the transfer of massive amount of data between the processor and the FPGA Fabric. The processing system also includes a DDR memory controller that supports DDR3 rates up to 1.3 gigabits per second. While this is more than the processing system would typically need, it also enables the FPGA Fabric to share the external memory with the processing system. There are also some applications that require even higher external memory throughput. For those applications, we offer a soft memory controller that users can implement in the FPGA Fabric to connect to external DDR3 memories that run up to 1.8 gigabits per second. Now, the last element that gives Zynq devices unmatched performance and power is the FPGA Fabric itself. Thanks to the 28nm HPL process and the block-level architecture of each of the fabric elements, Zynq delivers up to 60% higher performance on pure logic blocks and up to twice the performance level for hard IP blocks, such as DSP slices, compared to other 28nm FPGAs. This performance advantage also comes with significant power savings. Some of our customers who are using Zynq and comparing their measurement to the power spreadsheet provided by our competition have reported that Zynq provides up to 40% power advantage for applications such as wireless radio head. So when you look at it, the combined advantage of our 1 GHz processor, our superior memory and logic architecture gives Zynq unmatched performance and power that places it a generation ahead of competing solutions.